Hello everyone. Today in this video we are going to learn about the design steps of isolated footing. Okay, so you can see here basically we have to follow 8 different design steps for the complete design of the isolated footing. Okay, so now let's move on the topic. So we have design of footing, and in very first step we have to calculate the area of footing. You can see here in very first step we have to calculate area of footing required, and it is denoted by the small a, and a required equal to 1.1 p upon q. So here p means, you can see p means basically this p is a on factor load, and this q is bearing capacity of soil. So the value of p on factor load is already given in the question, and the value of q, that is bearing capacity of soil, is already given in the question. So with the help of this p and q known value we can calculate this area. Okay, with the help of these two values we can calculate the area required. Okay, so in next step, that is step number 2, we have to calculate the pressure under the footing due to some loads, or due to the superstructure load or any external load, there causes the pressure under the footing. So if we denoted the pressure as W, then we can calculate the pressure under the footing with the help of this formula. W equals to P U by A plus minus M by Z. If there is given the value of M, that is moment, then you have to use this formula, that is M by Z. And if there is no any value given, then you can neglect this M by Z term. Okay, so in the question they may be given moment. Okay, then if there is mentioned the moment, then you have to use this portion, you have to use this part as well. And if there is no any given moment, then you have to just take this value, this only, this much pressure, that is W equal to pu by a. Pu means, p means simply on factor load, but u means ultimate load. Okay, pu by area, and if there is a moment given, then you have to take this whole part. Okay, for the calculation of pressure, W equal to pu by a plus minus M by Z. Okay, so if you take, you can see here there is a plus minus. So what does it means? So if you take positive value, that is plus, then the pressure under the footing gives maximum value. And if you take this negative value, you can see here is a plus and minus. If you take positive, then here you can calculate the maximum pressure. Okay, and if you take the negative value, then you can calculate the minimum pressure under the footing. Okay, so you have to calculate pressure on the footing with the help of this formula, and in detail we will see in the numerical. Okay, so you have to just keep in mind that if we have to follow these all the steps. Okay, so in next step, that is step number 3, you can see in step number 3 we have to calculate maximum bending moment. Okay, so for the maximum bending step we have to follow two shear, one way shear and two way shear. Okay, so for the both case, for one way shear and for the two way shear, we have to calculate the maximum bending moment. Okay, and after that we can check the depth against the bending. Okay, in both way, in the one way shear also and the two way shear also. You can see in one way shear and in two way shear. So in the calculation of maximum bending moment, we have to calculate one way shear and two way shear, and after that we will check the depth against the bending moment in one way and two way shear as well. Okay, so this is in third step. Now let's move on the next step. Okay, so in fourth step, you can see, as I said, check for the depth against the bending moment in one way shear and two way shear. In both we have to check the bending moment. Okay, this is the fourth step. And in fifth step, you can see we have to calculate the area of steel. Okay, in previous we have done different numericals related to calculation of area of steel, and with the help of that formula we have to calculate the area of steel required for the footing. Okay, so we have to calculate area of steel in fifth step. And you can see next one is check for the development length. We have to calculate the development length and we have to check it is safe or not. Okay, if the value is development length is safe, then we have to go in next step, and if there is any not safe, then we have to increase the value. Okay, and you have to make safe. So after this, let's move next step, that is step number 7. Check for the bending. Okay, we have to check for the bending stress, and if the bending stress is also okay, then finally we have to do the detailing of this footing. Okay, and we have to show the different reinforcement detailing, that is the different steel required and the base, cover, and all the things. Okay, so with the help of this designing steps, we have to design the isolated footing, and in next video we're gonna see how to design the isolated footing, and we will do its numerical related isolated footing numerical. So stay connected. Thank you very much.